Section 10.1, the basic ingredients for testing with categorical variables. So that is the main difference between what we're talking about in Chapter 10 versus what we've talked about in the earlier chapters, is that now we're going to have categorical variables, not just numerical variables. So our hypothesis tests that involve categorical variables, they do follow the same basic four-step process that we've already studied. Some differences are that, remember, from way back at the beginning of the semester, categorical variables are often displayed in something called a two-way table. A table that shows the frequency of the outcomes. These tables can give the impression that the data are numerical, so you do have to be careful. Another word for a two-way table is a contingency table. And why this is important is that this is what it's denoted in StatCrunch. So you'll find yourself going to a contingency table area to do some of our calculations. Okay, the expected counts are the number of observations we would see in each cell of the summary table if the null hypothesis were true. There's a formula that we can use to find the expected counts by hand. That's by taking the row total times the column total and dividing by the grand total. The Chi-Squared Statistic is what we get from these tests. It's a statistic that measures the amount that your expected counts differ from your observed counts. So again, how much did what I expect differ from what actually happened? There's the formula for finding this Chi-Squared Statistic. It's actually one of the easier statistics to find. It looks very complicated, but all it says really is that we're going to take the observed value minus the expected value, square that, divide by the expected value, and do this over and over again and add them up. This is sum. Add that up